u.com.
Okay, welcome students. So in this session we are going to see ECG recording. Okay, so how to record ECG. So we are going to see ECG recording. Okay, let us see. So first we are going to see the objective. So the objective of this session is students can understand how to record ECG and ECG recording system and block diagram. Okay, so student can understand ECG recording block diagram and how to record and some real-time recording videos. Okay, right. Then the terms and terminologies used in this session is first one, lead system. The lead system is already we have studied in previous session. Okay, so lead system means electrode and recorder interface wires, that is a leads. Okay, so already we have studied 12 lead system for measuring electrocardiogram. Okay, second thing is CMRR. CMRR means common mode rejection ratio. This is mainly used in differential amplifier. Here we are using differential amplifier to amplify the electrocardiograph signal. So the CMRR should be very high, so the maximum value is 1. Then only we can achieve noiseless ECG signal. The next one is a pre-amplifier. The pre-amplifier is used to amplify very weak signal that is coming from electrodes. So the voltage range is in the range of microvolt or millivolt. This weak signal is amplified by pre-amplifier initially. After that we are using power amplifier. Power amplifier again amplify the output of pre-amplifier signal to derive the output devices. Okay, right. So these are the terms and terminologies used here. Next, the introduction of ECG. What is ECG? So electrocardiograph, the expansion of ECG is electrocardiograph. So it is a graph. So this graph represents the heart function, that means cardio. Okay, so the heart performance is represented in the form of graph that is done by electricity, that is a signal, that is the signal coming from our heart, so that it is called as electrocardiograph, that is a graph. Okay, in short form ECG. Okay, so it is shows the electrical activity of heart muscles. So our heart muscles is producing some electrical activity during the time of expansion and contraction. The recorded ECG waveform is known as electrocardiograph, that is a graph, electrocardiograph. The instrument that is used to measure electrocardiograph is electrocardiogram. Okay, ECG gives the valuable information about cardiac disorders. So main objective of measuring ECG is to measure the heart performance, whether the heart functioning well or not. So it gives a valuable information about cardiac disorder. So this is a cross section view of heart. We are having 4 different compartments and some valves. Already we have studied in previous session about this. This is a chambers of heart. Then it has 4 chambers: left atrium, right atrium, then left ventricle and right ventricle we already studied. Then the heart valves, around 6 different valves used in our heart. Okay. How the ECG waveform is generated, or how the ECG signal is coming through the electrodes because of the activity of heart. See this PNG image here. Initially, now see, initial starting point is the left atrium. Okay, then we are having very peak signal when the ventricles are contracting. Okay, right? Then after that we are producing small signal. This ventricle contraction is less, then the heart performance is very worst. Then the human cannot survey with low amplitude of this ventricle contraction. Okay, so this is a one complete cycle of our heart. Okay, so this is a heart waveform is represented by some coordinates. Okay, right? PQRSTU. Okay, the QRS wave is very important. The QRS wave indicates the ventricle contraction, that is used to pump out the blood from the heart. So QRS signal is weak, then the heart is weak. We can easily identify that the QRS signal is weak, then the heart is weak. Okay, then this is a table indicates the different waves present in ECG cycle. First one we are calling as P wave, that is a small amplitude initially due to the depolarization of atria. Depolarization means the contraction of auricle, the atria. So the amplitude range is very small, 2.25 millivolt. The duration of this contraction around 0.17 to 0.22 PR interval. It is not okay, that is a PR interval, that is called as PR interval, that is in seconds. Then R wave or QRS complex. So due to repolarization of atria, that means during a time of P wave the atria is contraction. Okay, then in second stage the atria is repolarized, that means it is expand. After that the ventricle is contraction. Okay, ventricle is contracting. So it is this QRS wave produce very high amplitude, that is 1.6 millivolt. The duration is around 0.07 to 1 millisecond. Sorry, 1 second, 0.1 second, sorry, 0.07 to 0.1 seconds. Then T wave, due to the relaxation of myocardium, that is a T wave. So this amplitude is very small, that is 0.1 to 0.5 millivolt. Interval is around 0.05 to 0.15 second, that is called ST interval. Then ST interval, that is contraction of ventricles. So here the amplitude is not mentioned, so actually see the ST interval. So this is a ST interval, the amplitude is they are not considered. Then after that U wave, due to slow expansion of fibers. Okay, that is less than 0.1 volt. Okay, the amplitude is very less than 0.1 millivolt. Okay, then the duration is 0.2 seconds. Okay, so this is the waveform description. Next we are going to see the recording system of ECG. Okay, recording system of ECG. See, a recording system of ECG has different blocks. The major blocks are defibrillator protection circuit, lead selection logic, that have the calibration circuit, to control the read selection logic. Then pre-amplifier, the output of pre-amplifier is given to power amplifier. Power amplifier output is given to display unit. Then display unit feedback is given to RC feedback network. Then RC feedback network is given to power amplifier. Again, the lead selection logic is feedback through auxiliary amplifier. Okay, so this is a basic block diagram of ECG recording system. Okay, so here in ECG recording system we are considered the lead system. Already we have studied the lead system in previous session. Okay, refer the previous video. Okay, right. Next we are going to see each block description. So first block is defibrillator. So the one end of the electrode leads are connected along RA, LA, chest and LL of the patient. RA means right arm, left arm, then chest, then left leg of the patient. Other end of the electrode passes through defibrillator protection circuit. The protection circuit has 4 buffer amplifier and overload voltage protection circuits. So main purpose of this defibrillator protection circuit is protect the human from high voltage shock. Okay, so this defibrillator protection circuit receive the input from the leads, that leads connects the electrodes. So this voltage range is very small, okay, in the range of millivolt. So this electrode passes through defibrillator protection circuit. Okay, the protection circuit has 4 buffer. Okay, what is buffer? Buffer means buffer is a circuit that produce 1:1 output. That means input equal to output, but it produce some electrical isolation. Okay, sorry, it's not produce electrical isolation. Buffer amplifier just used to match the impedance. Okay, match the impedance. So that is the gain of the buffer amplifier is 1. That is no amplification. Okay, see 1:1 transformer is there, so input and output both are same, but it is used to protect the circuit. Similarly, the buffer is also used to protect the 2-stage. Okay, so the buffer is act as a bridge between the electrodes and next level block. Okay, right. So the protection circuit consists of buffer amplifier and overload voltage protection circuit. Overload voltage means in case sometimes the voltage is very high voltage when compared to our actual voltage. At the time the circuit automatically break the connection, then it will protect the entire system. Then next one is lead selection logic. This block helps to select the type of electrode lead system. We can choose either bipolar or augmented electrode system. Okay, so the lead selection logic is connected between the preamplifier and defibrillator protection circuit. So already we have studied 3 different lead system in previous session. Okay, so this lead selection logic, it acts as a switch and we can select which type of lead you are going to use, whether you are using bipolar or unipolar or augmented electrode system. Okay, then calibration circuit. Calibration is the process that help to eliminate error in the system. Okay, generally calibrate means we are finding the error and eliminate the error in the system. Here any changes in the lead selection circuit result in artifact in the ECG output. So if you are changing any lead, if you are changing from unipolar to bipolar or bipolar to augmented lead system, then that cause some artifact in the ECG output. What is artifact? Artifact means noise, the unwanted signal. So the artifact due to the moving of switch, after that the vibration of or moving of lead wires. Okay, so the artifact is easily affect the ECG output because the ECG output is very low signal, the range of millivolt. So even the electric field and magnetic field and mobile phone signal can affect ECG output. Okay, right? So the calibration unit helps the technician to correct the error in ECG output. Okay, the calibration circuit that is used to calibrate the ECG output. Okay, the calibration circuit that connected to lead selection logic. Okay, calibration circuit is connected or control lead selection logic, so it controls the error in the system. Okay, next we are going to see pre-amplifier. So pre-amplifier means first amplifier, that amplify the weak signal that is coming out from electrode leads. So the signal is in the range of millivolt, 0.1 to 1 millivolt. Okay, so the instrumentation amplifier is or the differential amplifier used as a pre-amplifier. Actually instrumentation amplifier and or the difference amplifier both are same, but instrumentation amplifier having extra buffer circuit that is used to match the impedance. Okay, so an instrumentation amplifier and the differential amplifier with high gain and high CMRR is used as a pre-amplifier. So it is a high gain amplifier, it produces high CMRR and it reduces the noise. What is high CMRR? What is CMRR means? CMRR means common mode rejection ratio. What is common mode? In differential amplifier we are having two inputs, V1 and V2. So the input V1 and V2, if you are applying the two inputs, both are same, means the output should be 0. If the output is 0 when the input is same, that amplifier is good amplifier. Okay, that means CMRR is high. So the CMRR is mainly used to remove the noise in the system. Okay, so the instrumentation amplifier along with the difference amplifier, so that produce high gain and high CMRR is used. So high gain means 1:1000. 1 millivolt is converted into 1 volt. So it is amplify the given input signal to 1000 times greater. When we are amplifying this much gain, at the time easily the signal is affected by the noise. Okay, 1 volt to 1000 volt means 0.1 millivolt noise is, if considered as an input side, then that is amplified to 100 millivolt. Okay, so that is increase the noise in the system. So the high CMRR reduce the noise, so it is also called as low noise amplifier. Next one is a power amplifier. So see the block diagram, the pre-amplifier output is directly given to power amplifier. So the power amplifier amplify the pre-amplifier output and it derive the output units. Here the output units may be some pin. or some printer or some LCD display or anything. Okay, the output unit is driven with power amplifier. After the signal is amplified using preamplifier, it goes to power amplifier. The output unit is attached with pin motor. The pin motor that is used to draw the ECG graph. A high electrical power is required to initiate the recording with pin recorder. Hence, a high power gain amplifier are used as a power amplifier. Power amplifier is high gain amplifier or high current amplifier. Okay, this amplifier is derived the output device such as pen amplifier or LCD display or any other device. Okay, so the power amplifier is very important, that is used to amplify the pre-amplifier output signal. Then here we are going to see the power amplifier circuit. See the power amplifier circuit having three important terminals. One is input voltage, that is a input V in. Okay, so this is a input V in, and another one is a V out we are taking here. Then here we are giving VCC, okay, positive VCC. Here we are giving negative VCC and positive VCC. Here also negative voltage. Okay, so this power amplifier circuit consists of two major parts. One is the non-inverting operational amplifier, and another one is a push-pull transistor amplifier. Push-pull transistor amplifier. Here NPN transistor is used. T1 is a NPN transistor, T2 is a PNP transistor. Both are connected through emitter and base short circuited. Then input is given to base of the push-pull amplifier. Output is taken from the emitter of the push-pull amplifier. Both the collectors are connected with a positive and a negative voltage. Then the output is feedback to through the resistor R1 and R2, that is a voltage divider circuit R1 and R2. Okay, then this the non-inverting terminal, that is means the inverting terminal of the amplifier is connected with a potentiometer, that is used to adjust the gain of the power amplifier. Okay, so this is a circuit description. See, R1, R2 and 3 is a biasing resistor. R1, R2 and R3, these are the biasing resistor, there is a feedback voltage divider. Then RF is a feedback resistor. RF is the feedback resistor. Where is RF here? Actually I think RF is resistor. Yes, RF is a feedback resistor. RC is a collector resistor. RC is a collector resistor. Then T1 and T2, that is class B push-pull amplifier. So the non-inverting amplifier, that is used to avoid the crossover distraction. Actually the disadvantage of push-pull amplifier is crossover distraction. So between two half cycle it has some difference. So that is a crossover distraction. This crossover distraction is eliminated by this non-inverting of an amplifier. Okay, right. Then auxiliary amplifier. So the auxiliary amplifier is connected between, that is see that block diagram, connected between lead selection logic and left leg. Okay, sorry, right leg. Okay, so connected between right leg and lead selection logic. See, so the auxiliary amplifier purpose is it is connected between lead selection logic and right leg of the patient. The pre-amplifier cannot eliminate common mode signal completely. So the auxiliary amplifier used to reduce the common mode signal, so the CMRR is increased. Actually pre-amplifier is instrumentation and a differential amplifier, so it has high CMRR, but in practical this pre-amplifier cannot eliminate common mode signal completely. So in order to improve the signal, we must remove the common mode signal to zero level. So to improve the signal, we are using the auxiliary amplifier. Auxiliary amplifier reduce the common mode signal, and it is improve the CMRR in the amplifier. So this is actually amplifier we are using. The actually amplifier connected with right leg for reference output. Okay, right. Then feedback network. The feedback network is used to provide damping to the pin motor. See the block diagram. This is a block diagram. So the feedback network is a RC feedback network, resistor capacitor feedback network. So it observes the output of display unit, and it is provide desired value to power amplifier. According to the feedback value, the power amplifier derive the output device, okay, in right path. Okay, that is a feedback network. RC feedback network is used here. So feedback network is used to provide damping to pin motor. Okay, right. Then output displays. Okay, the output display is by CRO or pen chart recorder act as a output device. Okay, so the output device is a CRO or pen chart motor. Okay, recorder. Most of the in our government hospital we are using pen chart recorder. So they record the ECG in a paper. Okay, in a long paper. Okay, right. Then we are going to see the real-time ECG recording by one video. Let us we are going to play the video.
Hi there, I'm David, I'm one of the medical students. Thanks for coming in today. Can I just confirm your name and date of birth?
Sure, it's James Alexander, 30th of December, 1989.
Okay, James. I'd like to do an ECG today. It's an electrical tracing of your heart. It's going to involve me placing some sticky pads on your chest, arms and legs, and measuring the electrical activity of your heart. Would that be okay?
Yeah, sounds fine.
For this, I'm going to need you to take your top off and just lie down on the couch for me. Is that okay?
Yeah.
Good. Are you comfortable where you are?
Yes, sir.
Do you have any pain in your chest at all? Okay, I'm just going to start by feeling on your chest to work out where to put these leads. Okay.
So refer the previous lead system video. So based on that, they are connecting leads.
Just going to place some sticky pads on. So if you just relax your hands flat for me, just on the side. That's great, thank you. Just going to put some sticky pads on your wrist. And on your ankles as well.
This is a reference selector. Left arm and left leg and right leg we are considered as a reference selector. So these are the leads. So the blue color is these are electrode. This is a lead. Okay, these are lead. These are lead wire. Okay, these lead wires are connected with the recorder. a simple surface electrode. So this system are called as lead system. Okay, this is a recorder. Here we are seeing the ECG waveform. Then this is a ECG printer, that is a pen motor. This is a pen motor. That pen motor drawing the make the graph. This is a ECG graph. This
Okay, that's done. Thank you very much, James. I'm just going to take the leads off.
okay, the process is completed. Okay, thanks to this channel. Okay, thanks for watching. Thank you so much. I think this video is useful to understand the ECG recording. So please share and put like and subscribe. Share this video to your friends. They are studying in other colleges also. Okay, thank you so much. Thank you. Bye.